new unit is on exponents, and there are several rules for for solving exponents, expressions with exponents in them. And the first one we're going to talk about is multiplying. When you're multiplying exponents with the same base, you keep your base and add the exponents that are there. So some problems are simple. Some problems are just x squared times x cubed, and they have the same base, and you know that you're multiplying them, so you keep your base and you add your exponent. 2 plus 3 is 5, so that's x to the 5th power. Then you get into more complicated expressions where there are more than one base. So when you have more than one base, look at it as if you have multiple problems in one. So I always start with my coefficient. If I don't have a coefficient, then I just move on to the variables. But for this first problem, I have 3 e cubed times 7 e cubed. 3 times 7 is 21. Now I have e to the 3rd power times e to the 3rd power. I keep my base because I'm multiplying an exponent that has the same base. Keep my base, and I add my exponents. 3 plus 3 is 6. So the answer for this would be 21 e to the 6th power. You know you've reached your answer when you only have one type of base for each base that's left. So I have one coefficient, I have one e with my exponent, so I'm done. All right, number 2. 4 times, when you have parentheses, that's multiplying, negative 4. 4 times negative 4 is negative 16. Then I have r to the 4th power times r to the 3rd power. R to the 4th power times r to the 3rd power. Keep my base and add my exponents. 4 plus 3 is 7. So my answer is negative 16 r to the 7th. All right, number 3. I have negative 11 times negative 5. Negative 11 times negative 5 is positive 55. Then I have w to the 4th power times w to the 3rd power. 4 plus 3 is 7. Keep your base. And then all I'm left with is this x to the 4th power. There's no x in my first part of this expression, so I'm just going to keep my x to the 4th power. So my answer, whenever I put it all together, is 55 times w to the 7th power times x to the 4th power. All right, number 4, if a variable does not have a coefficient, its coefficient is 1. So when I have negative 4b to the 6th power times, remember parentheses means multiplication, times negative b squared c to the 3rd power, this negative b is the same thing as saying negative 1b. So I do negative 4 times negative 1, which is positive 4. A negative times a negative is a positive. Then I move on to my b. b to the 6th power times b squared. 6 plus 2 is 8. So that's b to the 8th power. And I'm left with this c cubed that I have to bring down because there's no c in the other part to combine it with, so I'll just bring it on down. Alright, that is how you multiply exponents. You keep your base, add your exponents. Make sure you're working these one base at a time. Alright, let's look at division. When you divide, if you have something as simple as this n to the 19th divided by n to the 11th, you're going to keep your base and subtract your exponents. 19 minus 11 equals 8. So this is n to the 8th power. If you have more than one base, then you always start with your coefficient and then move on to your other bases. I have 18 divided by 9. 18 divided by 9 is 2. divided by v is 1, so that leaves me with 4 v's on top. If there is no exponent written there, it's the same thing as saying it has an exponent of 1. 5 minus 1 is 4, so that's 2v to the 4th power. Alright, the next one is 24a to the 6th power divided by 6a to the 5th power. Divide your coefficients. If you can't divide it evenly, then leave it as a fraction. 24 divided by 6 is 4. I have 6 a's on top and 5 on bottom, so that's going to leave me with 1 on top. If you have an exponent of 1, there's no need to write that 1. You just leave it as 4a. Alright, and the last one, the only coefficient I have is 3, so I'm going to leave 3 on top. I have x to the negative 4th power. I cannot have negative exponents. Anytime you see a negative exponent, you need to go ahead and move it. If it's in the numerator, you need to bring it to the denominator to make it positive. If you have a negative exponent in the denominator, you need to bring it to the numerator to make it positive. You have to cross this vinculum, the fraction bar, in order to make a negative exponent positive. So I keep my x squared on bottom. I bring my x to the 4th on bottom. Keep it positive. Now that I've crossed the vinculum, it's positive now. Now I look and see, do I have any bases that are the same? Well, yes, I have 2 different x's on bottom, so I'm going to combine them. This is x squared times x to the 4th power. That's going to put me back to the rules I was just working with on the previous page. I'm multiplying with the same base, so I keep my base and add my exponents. Nothing is happening to 3, so it stays in the numerator. 2 plus 4 is 6. So the answer is 3 divided by x to the 6th power. This is how you divide exponents. Keep your base. When it's the same base, keep your base, subtract the exponents. One base at a time. Alright, the next rule we're going to talk about is raising a power to a power. When you have an exponent and you're raising it to another power, you keep your base and multiply your exponents. 4 times 3 is 12. So if you have multiple exponents, you keep your base. Do what's on the inside first. 3 times 3 is 9, and 9 times 2 is 18. When you have more than one base, you have to distribute to everything inside the parentheses. If there's not an exponent, it has an exponent of 1, and 1 times 2 is 2, so that's negative 6 to the 2nd power. Then we have 5 times 2 is 10, r to the 10th power. S to the 9th power, raised to the 2nd power, 9 times 2 is 18. And we want to put this negative 6 in parentheses because it's negative 6 times negative 6. You want to make sure you still have those parentheses there. Alright, same thing here. You've got n to the 9th power divided by n to the 4th power. 9 times 3 is 27. 4 times 3 is 12. I have n more than one time, so I need to divide this out. 27 minus 12 is 15. So this is n to the 15th power. And then when you have negative exponents, you have to cross the vinculum, the fraction bar. If it's in the denominator, you want to bring it to the numerator in order to make it positive. So we have 5 to the 3rd power times 5 to the 7th power. I have the same base and I'm multiplying, so that means I'm going to add these exponents to get 5 to the 10th power. If I just have one number raised to a negative exponent, then I'm just going to put it in the denominator. If there's nothing left on top, then I have to put a 1 on top, so I have a placeholder, because you can't just have a fraction bar and a denominator without a numerator. When you have a coefficient with your variable, the negative exponent only goes with the variable or the number that is right beside minus 2 is going to stay up top, while only the m goes to the bottom. So first I want to get rid of my negative exponents. Not my negative bases, just my negative exponents. So I have 5 times negative 2 in the numerator, and x to the third, when it crosses the division line it becomes positive, x to the third power times x to the 6th power on the bottom. 5 times negative 2 is negative 10, and x to the third power times x to the 6th power is x to the 9th power. Once I only have one of each base left, then I'm done. And that is all for the practice for today.